Imagine a world where data isn't just stored and shared, but actively leveraged, while AI-powered compute scaling allows you to transform raw data into actionable insights in real time. Today, we are going to explore scalable multi-warehouse architectures with the power of AI-driven powered scaling with Amazon Redshift Serverless and seamless data sharing that can change the way organizations collaborate, innovate, and grow. Let's dive deep into how we can build scalable and intelligent data systems. Good afternoon, everyone. Welcome to this session. My name is Saurav Das. I'm a senior product manager at co-presenters. Ashish Agarwal, who's a principal product manager at Amazon Redshift and leads Serverless. We also have a customer speaker, Praneeth Mandadi from Hilton. He's a director of platform architecture at Hilton, and he's going to be sharing his journey with us.
All right, thanks, Paul.
So this is our agenda today. This is a level 300 session. We're going to cover some advanced concepts on how to build multi-warehouse architectures. And then we'll move on to some real-world examples. And there's a pre-recorded demo to see things in action. And then we'll have Praneeth share with you his interesting journey with Amazon Redshift at Hilton and how he was able to improve the performance of his workloads. And finally, Ashish is going to sign us off with some best practices. So let's get started. So with a show of hands, tell me how many of you experience complexity with data in your environment? Okay, there's a lot of hands. And how many of you see data constantly changing in your environment? Okay, great. So this session is for you. So with the advent of Gen AI, your existing workloads, I think all of you are exploring Gen AI, your existing workloads are going to need to scale. You're going to acquire new data sets. You're going to integrate with new applications. And then you might need to also comply with some regulations, right? So there is no one-size-fits-all recipe that can give you a successful outcome because your organization has a diverse set of requirements and you have different objectives and you need to fulfill all of that stuff, right? So let's take an example of how a customer's journey looks like when they are dealing with and evolving their data platform and trying to harness the power of data. They start off with dashboarding and reporting use cases. And then what happens is as their data spreads across the organization, they start to build ETL pipelines, ingesting data from multiple sources, getting it from operational stores, getting it from data lakes, and they ingest this into a data warehouse. Now, as the data needs grow, customers want real-time insights, and they can get to them fast. In addition to that, they try and integrate with ML capabilities so that they can get predictive analytics. At this point of time comes the next stage where they're looking to monetize their data and get ahead of them. So they start to build complex architectures so that they can scale their data footprint. And they use data mesh architectures or different kinds of multi-warehouse architectures with data sharing in the mix. And at this point of time, they have so much data in the organization and everybody needs access to it, so they have to democratize access. Now comes Gen AI, right? And then with Gen AI, they're trying to build conversational experiences and they have to store even more data. So they have to further democratize data access. So with this, what I'm trying to get at is, let's take the use case of a Gen AI application. If you're trying to build a chat-based assistant, Gen AI assistant, you will first need to store extensive amounts of training data in your cloud data warehouse, right? And this is needed because you will want your chat assistant to get real-time insights on user queries from the data which you're storing in your data warehouse. It is the context the Gen AI assistant is building. Now, irrespective of whatever you do, if your data isn't ready, no large language model, which is going to be used by a Gen AI assistant, is going to deliver, right? So that's why what I'm getting to is that you need a very strong data foundation. And Amazon Redshift, we believe, can give you that strong data foundation. because it provides the scalability and the price performance for your growing workload demands. It allows you to get to insights in real time. It gives you access to a unified lakehouse with SQL capabilities. We just announced it today. And then it gives you the context you need for your GenAI applications. It powers that context, right? And then with all of that stuff, you have built-in security within Amazon Redshift, which gives you the peace of mind because the security features are a necessity today, right? So we want to introduce to you the multi-warehouse vision and the architecture vision that is behind all of this, right? That will enable you to build a scalable data platform. In this multi-warehouse vision, you can analyze and do analytics on all types of data while doing a data ingestion using different mechanisms. You can be using autocopy or copy jobs from data lake. You can be using zero ETL from your different AWS data stores, or you could be doing streaming ingestion if you have a streaming application in place. And you can consume all of this data across different BI tools, AI/ML applications, APIs, or third-party engines. But at the core of this vision, or at the heart of this vision, is a multi-warehouse architecture which is powered by Amazon Redshift Serverless and Amazon Redshift data sharing. And that is what our presentation is going to be about mostly today. So there are two components to this, like I said. And let's talk about the first component, which is Amazon Redshift Serverless. So we GA'd Amazon Redshift Serverless 2 years back. And this allowed customers to easily run and scale analytics without having to manage infrastructure. Customers today are running, tens and thousands of customers are running billions of queries on Amazon Redshift today. And as you can see the stat on the slide, most of our customers are running over 4x more queries in 2024 compared to 2023. So we have a lot of interest and customers are using this. And the reason is because Amazon Redshift Serverless automatically provisions and scales capacity, and you pay only for what you use, right? Now, we haven't stopped there, and we are continuing to enhance Amazon Redshift Serverless even further. We now have support for AWS Private Link for secure connections. We have introduced recently AI-driven scaling and optimization, which can give you up to 10x more price performance. And this is what Ashish is going to dive further deep into later in this session. You're going to hear the inner workings of this AI-driven scaling. Then we have expanded the RPU range to 1024 RPU, and this is double the capacity what we had before. And then we have expanded our footprint to 10 additional AWS regions. Now, the second component is Amazon Redshift data sharing, right? Data sharing allows you to share data across multiple data warehouses, right? And it is live transactional data which you can share without actually copying that data. And with Amazon Redshift data sharing, you can share data between a provisioned cluster to a serverless endpoint, or vice versa, or in any combination. You can share this data within the same AWS account, across AWS accounts, or across AWS regions. Amazon Redshift data sharing basically allows you to scale your read workloads and enables use cases like workload isolation and chargeback, right? And this is what's needed for organizations which are trying to scale and democratize access to data within the organization and also want the consumers to pay for it, right? So we've also added support for AWS Data Exchange, which allows you to subscribe to public data sets. And then you can see this is one of our most popular features out there. Customers are running daily tens and millions of data sharing read queries on Amazon Redshift. So with respect to the goal here is performance. So customers build multi-warehouse architectures with Amazon Redshift data sharing. And when they do so, there are two architectures come to the fore. One is data mesh, where if you have different units, business units within the same organization, say sales, marketing, HR, or research, and they all want to collaborate on the same set of data within the same account or across accounts, then they would use this kind of architecture. Now, if you want to centralize your data to a central data warehouse and then democratize access control from there, so to a BI tool or a dashboarding use case, or you have some ad hoc users on a computer and give them access, then you would use a hub and spoke model, and that's also again a popular architecture we see. Similar to Redshift Serverless, Amazon Redshift Serverless, we have not stopped enhancements over here as well. So we are enhancing data sharing continuously. So earlier this year, we introduced support for incremental materialized views on shared tables on the consumer side. So this allows you to, this is very critical for dashboarding workloads that need low latency. And it allows you to not have to do the full refresh the incremental data. The second thing which we introduced was scope permissions at a database or a schema level, so which allows you to grant access not only for existing objects, but for future objects which might get created under those schemas and databases. And then we have granular permissions at the object level, where as a consumer administrator, now you can grant access to a specific table or a view within a data share to your consumer users or a row. And to discover these permissions, we have a new SQL surface called show grants. It allows you to discover permissions at the schema level, the database level, at the object level, table or view for a particular role or particular user. And then similar to serverless, we are also expanding footprint of data sharing integration with lake formation to 11 more additional regions. So given that it is being used so much, performance is very key over here. So we've improved the performance of Amazon Redshift data sharing read queries in 2024 as compared to 2023 by 146x when the first time a data sharing read query is run. By up to 4x when the producer is getting updated. This is a use case when streaming applications are updating the producer data continuously and you're trying to consume from the consumer side. And then the innovation didn't stop there. So earlier data sharing was supported for only native Redshift tables, but now we have support for data lake tables. So you can just add a data lake table to a data share and give access to your consumers to it. You can additionally do a late binding view on top of a data lake table and add that to the data share as you could do for native tables. Now, last year at reInvent, we introduced to you the capability to do write operations with data sharing with a new capability called multi-warehouse writes through data sharing. And that was in preview. I'm pleased to announce that this capability is generally available now. With this new capability, you can start writing from Redshift databases to Redshift databases from different Redshift warehouses in just a few clicks. The data written once is available to all warehouses in that setup. Now, similar to how you can scale your read workloads with data sharing, you can even scale your ETL workloads and processing with data sharing now with this new capability. So you can allocate different compute for each kind of workload and isolate them. You can size them accordingly. And each compute can be charged back for the usage in terms of write operation it does, right? Another common use case with this is when you have different teams trying to collaborate on a same data set. So in this diagram, you can see sales, marketing, and finance trying to collaborate on a single customer 360 data, and they can write to it with just if data sharing is enabled for them. So how does this work? Well, we have not changed the surface much, right? The SQL surface remains the same. In addition to what you would do before, you obviously have to start by granting at least usage on the schema, which you're adding to the data share. But in this case, if you want to do creates, you would add create or alter or drop capabilities, right? You have that ability. Then you would add objects to that schema, under the schema. If you're defined scope permissions on the schema, you don't need to do that. But if you're adding specific objects, you can specify the permissions for those objects. In addition to you can grant, write, update, insert, delete, whatever is available, you can do all of that stuff. And then once you have done that, you choose who gets access. A namespace or account, a series of namespaces, you decide, right? This remains the same. But there's an additional step here. If you're doing cross-account data sharing with write, then you as a producer administrator will need to grant allow write access. Otherwise, by default, you'll have read access. Now, on the consumer side, you, again, if you're doing cross-account data sharing, the consumer security admin needs to come in and allow the data share and allow this. Otherwise, it would not. This is like a veto power we have, which we put in there as a check. And the consumer admin needs to take care of that. Now, once you've taken care of all of that, you can create a database, just like you could do before, from the data share. And I'll cover some of this in the demo as well. You can do this with permissions or without permissions. Now, if you're doing this with permissions, you have the ability to grant granular object level permissions, which I was talking about before, right? So that's the next step, right? So if you have not granted access to the whole database, you could do with permissions, and you can give granular access to specific objects within the data share. You can isolate access through roles, you can give it to specific users, as you please, right? But we give you that flexibility to do that. Now, we have done the same thing in the console. We've tried to refine the experience further and made it more intuitive. And at this point of time, I'd like to hand it over to Ashish, who's going to dive deeper into AI-driven scaling with Amazon Redshift Serverless and take you and share some real-world examples of multi-warehouse architectures.
How many of you have experienced difficulties in scaling your capacity for your data warehouses? Can you please raise your hands? Quite a bit of it. And how many of you think that you are under provisioned or over provisioned or paying relatively more for your data warehouse? I see many hands raising up. All right, so you're at the right place. I'm going to help you solve that problem. All right, so Saurabh explained about some benefits for Redshift Serverless. Redshift Serverless, we have made it even more smarter with the new AI-driven scaling and optimization that gives you 10x better price performance. It solves three specific, it is even more smarter now. It helps you in three specific ways, which I'm going to explain real quick. It meets your price performance targets based on the slider you see there, optimizes for cost, optimizes for performance, and in the middle you see balanced. So it will try to meet one of your targets. So the first one is it holistically looks at your workload. It continuously learns about your workload requirements, resource requirements, and it sizes according to that. There is no more sizing that is needed. You do not size with anything. It's truly serverless. That's the first scenario. Second one is, let's say suddenly a resource intensive query comes in. It is intelligent in near real time. It goes and allocates enough capacity to make it run as fast as you want to, given your price performance target. And in real world, what happens is our data grows and we still want consistent performance. How do we help with that, right? Because you're scanning more blocks. Today you may be scanning 1 terabyte for a query. Tomorrow, if you load more data, you may be scanning 2 terabytes of data. But we still have business to work and get them better performance. So this AI-driven scaling and optimization will help with that scenario also. Okay. So it's intelligent, it's smart, and it meets your price performance target, giving you very consistent performance. Okay. What do I have in the console for you? So if you look, there are two options: base capacity, which exists today. We have added the price performance targets. So based on your requirement, the first one on the left hand side, if you see, it is optimizes for cost. It prioritizes the cost first and then performance, still gives you great performance. Okay, there may be certain workload that you may run with great performance, but at limited cost or a limited budget that we have. On the other hand side, if you see optimizes for performance, that actually prioritizes the performance more than the cost actually. That will give you the best possible performance. The cost may increase, but it will give you, we have critical workloads, right? C-level suite workload, right? You may want to run their reports as fast as possible and get goodies, right? So that's the option for us, and in the middle is the balanced. So our recommendation is to keep it balanced, and that one, everything is dynamic in nature. You are welcome to change anytime. It takes time to go impact, to make it effective. So little bit insights here, how does it work? So the first component is workload forecaster. What it does, it observes the pattern over a period of time, let's say a day, 2 week. It continuously keeps observing the pattern, the requirements, and then it does a what if analysis. It predicts like P50, P90 of the workload, for example, and say, hey, can I run faster? Or other way also it looks, can I save you on cost actually? At what optimal capacity can I meet your price performance target? It continuously evaluates your workload and makes a decision. It does that work for us. It's basically a mind of a brilliant scientist that's inbuilt in the system, and that's what it makes it, AI driven scaling, and very specifically, again, these are insights, that it uses the sampling and distribution forecasting model to come to a conclusion. The second component, I mentioned that, let's say a heavy resource query comes in near real time, it does the analysis and scales. Okay. So how does it do that? Because there is a query forecaster inside this AI driven scaling optimization feature. It keeps track of the query properties and keeps track of what is kind of resources is needed and does a what if analysis and comes to a conclusion. If I increase the capacity or decrease, both ways, can I run it faster or at a cheaper cost? It does that analysis and meets your price performance target. It's not tied to the SQL text, but it ties to the properties like, hey, what kind of joins I am doing? Am I doing a merge join or a hash join? That will require more resources, right? It keeps the statistics, number of blocks that we are scanning, or the NDV values in mind, and makes a call. So more than 50 properties it actually keeps track and automatically makes a decision on our behalf. Then there are 3 specific models to give you a very quick answer in near real time. It has a cached model, because if the query is repetitive in nature, it memorizes, hey, for this particular query, same exact query, I have used this much compute, so I quickly go and allocate more compute for you. Then there is a locally trained model. If we have seen a similar query, your query text may remain the same, but the literal values may have changed, right? So it goes and uses the locally cached model. And if the query is new, completely new, there is globally trained model also. So all these models are extremely well built and well designed to help and solve real world challenges. So far we have learned about Redshift serverless, data sharing, and how we are using AI to enhance serverless and solve your real world problems. Now let's look at some real world examples on how our customers have implemented. I really want to share that architecture with you so you can take it and see if that fits your needs. Okay. So the first one is a logistic company. This is a monolithic cluster. They are there for a long time. This is a very common pattern that's there out in the industry. The data lands in S3. They do an ELT, basically load the data into Amazon Redshift provisioned cluster, and then do the transformation. It works well, but the challenge is the data sets are growing. Okay, and there are 2 types of data sets for this logistic company. One is the actual order coming in, which is very small, and the other one is the tracking of the order itself, which has constant updates, right? Hey, my package is here, my package is loaded into van, my package is in this post office. So that data set is 5x more larger, and same users are querying that data sets. That creates two set of requirements, and on top of that the transformations is happening at the same time, and the data itself is growing, users are growing, ad hoc queries is also happening as business is growing, right? So that actually started resource contention. So that was the current problem with this customer. We sat with the customer, we looked at the workload, we advised them to split the workload, use this multi-warehouse architecture. So we split the workload, it's the same application. So if you look, we loaded the data for the two types of use cases into two separate Amazon Redshift serverless. Because it's workload isolation, two data sets sized for their own needs with workload isolation, as well as taking advantage of the auto scaling capabilities of serverless, both together. And then using data sharing for the Power BI users as well as for the ad hoc queries. So that was sized according to that its own need. In the end, the customer was experiencing the workloads for up to 12 hours have now been completed in 2 hours, resulting in much better performance, meeting the business needs as well as the saving on the cost. The other example, workforce management company, from the get-go, what they did was they were consuming from their operational data sets using the Amazon managed Kafka MSK into serverless, where they were doing the transformation, but they had two use cases here again for two different needs. One is to give insights to their customers, external customers, to the workforce data that they were collecting for compliance, reporting and other needs. And other one was for their internal users for the customer analytics itself. So they did data sharing to another one, and as a result from the get-go they were saving cost and resulting in a better performance. So that's another pattern that we implemented with a customer. The third one is for a financial company. It's a fraud detection analytics use case. As soon as the data landed, they had a need to report it back in 5 minutes. Okay, so what did they do? Okay, again the data sets were different for different use cases inside the company, right from transformation of the data as well as different reporting needs, ad hoc users internally as well as for their external users on the fraud detection cases. They loaded the data from Amazon S3 as well as from their operational databases using the Amazon Kinesis data streams. So if you look, it's a true data mesh architecture. They have used Redshift serverless, they have used Amazon Redshift provision and shared the data across two Redshift serverless instances for near real-time reporting as well as for ad hoc analytics. Okay. Workload isolation benefit, each of them were isolated, no resource contention or less resource contention because of this architecture, and the auto scaling capabilities. All three serverless instances were benefiting from the auto scaling capabilities, especially the BI workload where it was variable also, the workload was variable in nature and they could not predict how many users will come in and how the data is increasing over the size or the complexity of the query. End result, better performance, meeting their SLAs of less than 5 minutes, and also the cost savings were quite significant for the customer. So we learned some patterns. Another real world use case, it's a very common scenario we see. ETL jobs, they require more resources typically, right? And they run during certain times for many of our customers. Let's pick in the night you have ETL workload, right, where you require more capacity, and in the daytime we have reporting or BI workload which requires less capacity, right? The challenge is again sizing it. Either you can oversize it, pay more, or undersize and perform less, or take manual actions to keep doing it, which is very harder in today's world. So because of Amazon Redshift Serverless, in the afternoon it will automatically scale, because I explained the AI driven scaling and optimization. Because of that, it will automatically scale to 64 RPUs, Redshift processing units, which is the unit of measurement for cost and resources for Amazon Redshift Serverless. It will scale to 64, hypothetical example, but happens in real world. And in the night, because it learned the pattern proactively, even before your ETL job starts, it can scale back to 128 RPU to meet your price performance target, give you consistent performance just for the ETL workload. Okay, maybe it is few hours, maybe it is couple of hours, or whatever kind of ETL job you're running, and then it will shrink back to 32 automatically. That's how you will get optimal cost. Okay? That's the value of AI driven scaling and optimization. What I would like to do is, we have explained you, I like to invite back Saurabh to show you a demo on exactly what I have spoken here. Over to you, Saurabh.
Thank you. Thank you. Okay, so I think you guys must be thinking, hey, Saurabh and Ashish, you're telling me about these wonderful capabilities, but does this work? So we're going to show you a demo to see these things in action, right? So, so I'll just explain what the demo is, and then you can we'll actually show you the actual demo. This demo, in the interest of time, is recorded, and for internet connector issues, and also we have fast forwarded some of the segments because we don't want you to be waiting for data to be loading. So as you can see over here, I have 3 serverless endpoints. All of them have AI-driven scaling enabled. I have the main producer on the right-hand corner, and this main producer is optimized for price performance, so it's in balance setting, right? And this is where which is the owner of the data. And then I have 2 consumers. One is a write consumer, which is ETL consumer, which is optimized for performance. I'm going to be running copy jobs from this consumer using data sharing, multi-warehouse writes. Through that data share, which you see ETL demo, it has write permissions to go and ingest data. And then I have another consumer, which is a BI consumer, which is optimized for cost. I want to save cost here. This is for my ad hoc users to run some aggregation and queries. And it's going to be reading data with only read permissions from that read data share BI demo. So let's get into this demo. As I explained to you, I granted usage to those respective namespaces on those 2 data shares. You can see these 2 data shares. And if I run a show data shares command here, you're going to see those 2 data shares on the main producer. I'm on the main producer right now, right? So now I have a bunch of tables here which are belonging data set for a retail company, which has cataloging data, call center data, sales and returns through the store, sales and returns to the web. So I have different tables for all of this stuff, right? I'm going to start off with the call center table, which has very few records. Right now, if I go and select the count of star in the main producer, these tables are all shared. You'll see 0 rows over here if you go and check the count. Now, I will go into the ETL consumer, and I can use the ETL DB, which is the database creator of the data share I explained before. And this has write permissions. And I'm going to go and check the count of that table through in that consumer, right? It's 0 rows. Now, I will ingest data through a simple copy command. It has about 40 something records. So I'm going to go and ingest some data into this table. This job is going to complete really quickly. So you see 48 records over there. Now, for the same table, if I check the count, it is 48 records. I will go back to the main producer, and the same table, which had 0 count, will show 48 records right now, right? So there it is. Now, let's not stop there. So we are going to show you more about AI scaling as well. So we'll go back to the consumer. We have all these tables which have billions of records, which need to be ingested. And we're going to use the ETL consumer to ingest those records and have started the copy jobs. They're going to take some time, right? But meanwhile, while these jobs are running, we're going to go into the console, into the serverless dashboard, and into the resource monitoring page, right? And there, if you go to the resource monitoring page, you will see all the different serverless endpoints I have and the various settings they have. So I'll select the ETL consumer over here. When I select the ETL consumer over here, it's going to tell me the RPU usage and how it is scaling over time as you're running write operations for a while now and done multiple iterations of it. It has automatically figured out optimized for performance is 128 RPUs for these copy jobs. Obviously, it's relative to your workload. It might scale even more depending on what it needs for your workload, right? So this is the optimized for performance setting for here. Right? Now I come back here and you'll see that these jobs have completed, right? I have fast forwarded this demo. I didn't want you to wait. And there are billions of records which were ingested across. Some have 8 billion records, some have 4 billion records, some have 2 billion records. And this data is ingested, it's ready. And if I go back to that dashboard, fast forwarded in time, you will see it used 128 RPUs as the base again, because it figured out it needs that much RPU for it to run these copy jobs. Now, we are going to go back into the query editor v2 and go to the BI consumer. This is the consumer which is using the read data share. And over here, I've created into the BIDB, which is created from the data share BI demo. And I am in the BIDB database here. So you can do this through the dropdown in the console, or you can do using the use command on SQL. Now I have a bunch of aggregation queries here which are comparing sales in current and previous years. These are all read queries on the ingested data I just ingested right now, right? So I'm going to run all of these, right? All of these, I'm going to run all of them one at once. And they're going to take some time to run. But we are going to go back again into the console and check the resource monitoring and how the compute is scaling through AI-driven compute scaling feature of serverless. And you'll see when I select BI consumer, it shows me it's 64 RPU because I told it optimize for cost. This is for my ad hoc users. I don't want to pay too much for compute. So it will determine what is the optimal RPU here, and it is 64 RPUs in this case. With this, we'll pause the demo over here. And I'm so glad that I want to invite Praneet Mandadi, a customer speaker, who's going to share Hilton's journey on how they scale their data platform architecture.
Thanks, Saurav. Good afternoon, everyone. So my name is Praneet, Director of Platform Architecture at Hilton. Today I'm here to share Hilton's journey into Redshift serverless implementation and how the serverless architecture and its services helped us solve a complex problem. Before I get started, how many of you have stayed at Hilton or any other hotels, right? Great. So when you make a booking, it generates some sort of reservation data, right? And then when you actually go and stay at the hotel, like when you make any changes to reservation, it does generate a lot of data behind the screens. And then when you actually check out, it does generate a different set of data, which is more of financial in nature, right? So this application that I'm going to talk about is kind of leverages this information, runs some analytics on top of it to support the property owners, those Hilton property owners, right? So let me move ahead. So the Redshift serverless, as Saurav has said, kind of became GA 2 years back. So prior to that, so the slide that you're seeing on the screen is our current implementation before we started into the serverless journey, right? So we had 2 provision clusters, and they were kind of, we have multiple business applications hitting those 2 clusters directly. This was set up when we were still in the DC2, DS2 kind of mode at the time, the storage environments. So one was ETL-based cluster where the ETLs are running, and then the other one is a compute-based cluster set up to specifically support a critical application. Right. Now, coming to the product or application that kind of helped us or kind of helped us started looking into the serverless. This application, as I said, leverages the reservation data. Now, the key things about this application was more of a challenge for us from an architecture standpoint. There are 3 basic requirements for this application. One, as I said, this application is used by property owners, and we have properties across the globe close to 80 countries. So these applications will be accessed by close to 35,000 plus users across the globe from different countries. Number two, with that number, it requires high concurrency. It means at any point of time, I can expect close to 100 to 150 property users clicking that execute button in the dashboard at the same time, at the same second, right? That's the expectation. Third, when they hit that execute button, the results should come out within less than 30 seconds. Now these dashboards, when I say these queries, are not single line queries. A single dashboard generates 100 to 150 line SQL queries, parallel queries. So that means each of those dashboard in return generates hundreds of queries on Redshift, right? So these complex analytical queries has to execute and get the result within 30 seconds. So these three requirements, we started looking into, okay, how can my existing Redshift provision environment can support this? It cannot, right? This is a high scale environment, high performance you're talking about. So we started looking at other stuff, but one key thing that I have from an architecture standpoint is my entire data, the warehouse data, is sitting on Redshift. So why can't I come up with a solution where I don't have to copy the data, which is the biggest hurdle, right? You guys agree with me from an architecture standpoint. I don't want to deal with moving the data, right? And the other thing that I forgot to mention is, as I said, I have property users across the globe, right? If you take, for example, someone operating from China, right? We are already, from EST zone standpoint, I'm already 12 hours behind. So even though I get the data transaction in real time, I have to create facts and dimensions out of it. At the time, we're just running it every 6 hours or 12 hours. And then the current implementation, prior to we getting into serverless, we used to ingest all of this data into MicroStrategy cubes. This application is sitting on top of MicroStrategy. That ingestion, talking about 2 years worth of transactional data, used to run for 8 hours. So by the time I complete that ingestion into MicroStrategy and refresh the cubes, the person sitting in China is already looking at the data which is 36 hours old, right? So one key requirement for this application is follow the sun. We don't want the user running the query from across the globe not to wait for 36 hours, but rather look at his data within 1 to 2 hours max time limit, right? So with that thing, we started looking into serverless, and then prior to serverless, we have already tested the data share piece that Saurabh has covered. With the provision cluster, if you remember my earlier slide, we had an ETL piece that was running between two provision cluster. So we started trying to replace that ETL piece with the data sharing mechanism. It worked well. So we are familiar with the data share piece, and we started kind of playing around with the serverless before this product app requirement came into the picture. So we have an idea that, okay, probably serverless with the data share and its feature can help solve this problem. So with the help of AWS team, we started venturing into this journey of, running to see what are the kind of architecture that I can come up with to solve this particular problem. Let's see what that is. So started with POC number one, which is kind of setting up a dedicated provision cluster, right? We went with the provision cluster because I want to see what level I can do a stress test on the provision cluster before getting into serverless. So we had set up a dedicated provision cluster and enabled the data share to the provision cluster. And that is a 7-node cluster. So from compute standpoint, it's a big, massive cluster. But it performed really well when the concurrency was slow. But as an added more number of users, when the concurrency increased, it was not able to scale. Because at that time, I'm not worried about compute, I'm worried about I/O, right? So this provision cluster, it's not able to scale horizontally. So then the max response time, the good response time that we got on the provision cluster for this type of workload was around 5 minutes, which doesn't work for us. We're looking at 30 seconds SLA, right? Then we moved on to the second POC, like next step is replacing that provision with a serverless, single node serverless cluster, right? The RPUs, as Ashish was covering, it's scalable, right? I can scale the RPUs. It's a compute. I can scale it. We started with 32, and we went all the way up till 512 RPU and tested this application at different RPU levels. Now, compared to what we're getting on provision, this architecture worked really well. As you can see, we're getting responses around 3 minutes. And the other thing, the setup 2B is, these are data shares. We started with leveraging data share, but even though the data share is fast, but I'm looking at a 30 seconds response time. So what we thought is, okay, how about localizing the tables on the serverless cluster. Well, I might get few seconds here and there, which is really good for me. So we started localizing the tables, right? We're sharing the data, we're refreshing the data, these facts and dimensions at a regular frequency on my provision cluster, sharing the data, and then localizing. Localizing is just creating a physical table out of it. That doesn't take much time. And we make sure there is no impact to the application when we're sweeping or switching the view mechanism over there. Now, with this setup, we're still getting my good response time was 3 minutes, which is not good enough for me, right? So then we expanded that into a multi-node serverless cluster sitting behind a load balancer. Now this kind of worked wonders for us. Number one, earlier I was able to scale it horizontally, scale it vertically with an RPU, right? I can change the RPU, which will change my compute. So I'm able to scale the cluster vertically, going up, going down, but I was not able to scale it horizontally. With a multi-node cluster, now I have the ability to scale it horizontally and also vertically by changing the RPUs. So when we tested this with this architecture, we started with a 3-node cluster, went to a 5-node cluster, went to a 7-node cluster, came back to 3 and 5. So we simulated this exercise. All this is happening in production. We simulated the number of users. We add the same data, same amount of data, and we tested this scenario. So we got a sweet spot. So when you look at the compute, the vertical scaling or the horizontal scaling, the number of nodes, there's always a number which works as your sweet spot for your kind of application, right? For example, if I have an application that requires X amount of CPU, let's say 96 RPU, even if I give 200 RPU, it might not benefit the application because that application requires only that much compute. Similarly, on the horizontal scaling, I can spin up 9 clusters, but it might not gain I might not gain any advantage because that application, based upon its compute and workload, it's good enough if I just give that 3-node or 5-node, right? So for our workload, for the kind of user base that we have, and for the kind of data that we have, we figured out a 5-node cluster with a 96 RPU might work for us. These are all testing, mind, right? So with that, let me share, before I go there, let me share the test results that we got. One of the test results, right, where you can see the numbers. So these are the test results for 1 week run in production for the 5-node cluster. As you can see, during the 1 week run with the simulations, 600,000 queries were hitting this cluster. NLB, and NLB was distributing the load evenly across the 5 nodes, right? And if you look at the ones that marked as in the star, those were the select queries that exceeded more than 40-second time limit, right? So as you can see, less than 1% of the queries exceeded that 40. Even though it's not shown here, but when you look at the queries that exceeded 30 but it was still less than 1%. So 99% of the queries, I'm talking about 600,000 queries over here, 99% of the queries were able to get the results back in 30 seconds, right? So this kind of helped us or proved that, okay, the architecture that we're getting into is scalable, it's going to serve the purpose, and it's going to help getting the response time. With that in mind, we deployed the architecture almost 9 months back. And this is what the metrics that you're seeing on the screen is as of October. We started with 500 users. We still are at 5. We started with 3-node serverless cluster with 96 RPU. We are at 5-node right now supporting this application. And today we are at 31,000 users got deployed onto this cluster with the 24,000 active users actively querying this across 79 countries and 64 reports in production. So we deployed, we kept on adding more and more dashboards to this application. Platform didn't change much. It's still, we started with 3-node. Only thing we did is kind of added 2 more nodes somewhere like 3 or 4 months down the lane when we added more users. RPU is still 96, and the max was 128, but now we got it down to 96 because we didn't see a need for it. And the average execution time is 10 seconds. I did not make these numbers. This slide got it from the business, the project team, the product team. They generate this, the monthly newsletter, so they kind of presented it. So this tells us that this serverless architecture that we kind of designed to support this application was a big success. Business is very happy with it, right? Now, where do we stand today, right? From an architecture, I mean, this is just one of the many projects that we support, right? So where do we stand from a data platform standpoint or architecture standpoint? The top section that you're seeing is the product application that we just talked about. As you can see, I keep talking about 5 nodes, but you're seeing 7 nodes over here. The reason is we did add 2 more nodes, but as a standby. They were not added to the parameter group. We added the nodes, set up the data share, but I'm not incurring any cost but having those nodes because they're not added to my set. But whenever the workload increases, whenever there is a need, in a matter of few minutes, I can add these 2 nodes to the parameter group. So that way there is no kind of impact to the application, right? And the bottom section, if you can recollect my first slide, there I was showing, I showed 2 provision clusters and the business line LOBs hitting the cluster directly. But today, we kind of start implementing into the hub and spoke model for one of the core cluster, which is ETL cluster. Now I'm isolating the workload, spinning up their own dedicated single node clusters. So that way, my ETLs don't suffer. At the same time, my consumption queries are not suffering. Now, this is our current state. Where do we want to see? We do have a target state architecture, and this is what we want to end up with eventually. With everything, I don't want any consumption application hitting my core ETL cluster so that our ETLs can run effectively. We do a near real-time ingestion. So it's our ETLs runs every 2 minutes, right? Continuous ingestion to the warehouse. So I don't want any consumption queries impacting ETL and vice versa. I don't want ETL queries impacting the consumers. And my consumers, some of them are technical consumers. Yes, some of them run simply the select queries, but some of them do run their own ETLs, right? So this is the target state architecture that I would like to get into. Eventually, we'll be there probably in the mid of next year. Now, this, if you recollect Saurav's presentation about serverless implementation, he talked about mesh and hub and spoke. This is hub and spoke, but with this new feature that became GA on the serverless, which enables me to write data into the data shares, I can convert this into a data mesh architecture, right? Because that was a limitation that we had. Now with a writable capability on the data shares, I can kind of mix and match and convert this into a mesh architecture, which is Insights. So now we did all these things from an architecture standpoint. We implemented it. The product was successful. But what is the business value I'm getting it? I know I touched on a couple of things, but if I have to go back to take this to the VP and explain, hey, I want to implement this, the first question I'm going to get asked is, what is the business value that we're getting out of it, right? So let's cover this in a little bit. So with this architecture, serverless and hub and spoke, what is the value that I'm getting? Number one, let's start from the top, workload isolation, right? I know that's one of the biggest challenge that we architects face every day, right? Where the ETLs, consumer queries hitting the same cluster. With this serverless hub and spoke, workload isolation is the biggest thing, right? My business is happy. ETL are running seamlessly without any issues. Number two, faster time to insights. With the data share enabled, and with the serverless and the data share, now business don't have to wait for the data to be kind of moved to their cluster, right? With the sharing, data is available real time. So now, and with a dedicated cluster for them, I'm getting into self-service architecture, giving them more accountability. Now they can run their own ETLs. I do have few use cases, few applications where they want to run their own ETLs. They do that today. But with this autonomous cluster, they're getting more freedom. So that improves the faster time to market. Next, reduce admin overhead. Serverless implementation, as I said, we started with 3 node, went to 5 node, went to 7 node, and have 2 standby nodes. This is all admin work. It takes to add a node or to remove a node, increase in RPU, decrease in RPU, it takes 3 to 5 minutes. That's it, right? Imagine doing that on a provision cluster. It takes time, right? So that's the biggest advantage that we have from a cloud DBA standpoint. Enhanced productivity, as I talked about self-service ETL, now I'm giving a business application who have ETL developers or tech savvy, giving them their own cluster, giving them their own playground to do whatever they want. Earlier, they used to, since they're operating on a core ETL cluster, it comes with a lot of rules and regulations, right? You cannot do this, you cannot keep a table for too long, you cannot run queries while ETLs are running. Now, all that noise is gone away, right? So now I'm giving them their own dedicated cluster. Whatever operations they do on that serverless do not impact my core cluster. Chargeback capability. This is my biggest business value that I'm going to rate when I have to go back and talk to my VP is with the provision cluster, with all the applications hitting the provision cluster, there is no way for you to figure out which application is contributing how much to your platform cost because everything comes as a bundle. End of the month, AWS tells you that your Redshift provision cluster is costing you $100,000, but there is no way for you to know which application has contributed to the cost. With the serverless implementation, every serverless cluster comes with their own cost. I can go back and say, hey, your application is costing us this many dollars when it comes to the platform cost. And we can work with them, sit with them either to optimize, to reduce their cost, right? That's a big thing. Improved performance, yeah, with scalable compute, RPU scaling up, scaling down, performance is, and I don't even have to change the RPU now, as Ashish covered with a new GA, with a new feature that became GA now. I can have the AI adjust my price and performance, right? I don't even have to change the RPU. That's another advantage over this one. Scalability, as we talked about, it's very easy to scale this cluster, scale this architecture, right? I don't have to think much. I don't have to spend hours together. Or DBS have to spend hours together to kind of scale up or scale down this cluster. So this is a quick summary on what Hilton did and how the Redshift serverless and this feature helped us to address a problem. Thanks for your time. I'm going to hand it over to the Ashish.
Thank you to Praneeth and Hilton team for believing in us, implementing Redshift serverless and data sharing, and helping business and improving the lives of their customers. What I am going to cover is, with all the learnings we have, what are the best practices, okay, in implementing that. I want to cover you that. So for the first one is, when implementing the multi-warehouse architecture and doing data sharing, clearly define ownership of each of your data sets and data shares. Very critical. Appoint stewardess for accountability. So who is accountable, okay? And implement security and governance models in place. Document it very well, okay? The second one is implement for real-time data sharing, build data mesh architectures. It will help you to democratize the data, increase the use cases, bring more value to the data that is being generated for your organizations and businesses. The AI-driven scaling and optimization, use that. It takes the pain out of your sizing completely. Whether it's a study workload, whether it's a variable workload, whether it's an unpredictable workload, it will give you the right price performance. Implement Amazon Redshift QMR rules, so that you control the resources as well. Monitor your queries, and that will give you the best possible performance. Establish data security, use IAM roles with least privilege principles. Use Amazon AWS Lake Formation to implement security and governance. This should help you with your both data mesh and hub and spoke architecture. Okay? Cost management, which is, I'm sure everybody wants to take care of it. So implement AWS anomaly detection, so that anything unexpected that may be happening in your environment in relation to cost or usage will reflect back in the anomaly. Generate automated reports for your data shares, okay? And also implement the capabilities that Redshift serverless data warehouse provides to you in terms of your cost controls. So by implementing this, you will always be under budget. There is max RPU hours that you can set the limits. There is max RPU capacity settings also. You can control the scaling. So use this. And finally, review, get feedback from your users. Okay, each businesses are unique. The needs of your business and individuals are unique. Talk to them, get their feedback, evolve your practices over a period of time. This will make you better. Your data mesh architecture, your multi-warehouse architecture will get better and better because of the feedback from your users. I want to let you know that you can test your conversion of monolithic architecture to this multi-warehouse architecture using Amazon Workload Replicator or Test Drive. You can capture your workload, replay in your environment, super easy to do it. And to do that, I mean, there is a $300 free credits for Amazon Redshift Serverless specifically that you can use if you are a first-time user to this service. I am leaving some resources for you here. The first one is a blog on the AI-driven scaling and optimization. And the second one is actually a GitHub repo with 2 notebooks. You can experience the price performance, gain yourself, download this notebook, import it in your Redshift Serverless and play with it. You will see how the AI-driven scaling and optimization works for you, and how to scale the right workload using the multi-warehouse architecture. That also you can have a very nice blog there. Thank you so much. We appreciate you being there. Kindly fill up the mobile application, feedback in the mobile application, and we will be available to take question and answer outside of the room. Thank you so much for being here today.